Hey guys, welcome to ANS Solver. Today we'll be doing the concept of differential equations, which is a subtopic in the chapter of differential equations. Okay, so this topic is mainly based on integration. Okay, and it's a really simple topic and it comes for around 6 to 8 marks in your paper. Okay, so it's easy, but it's a very important topic. So what they'll do is they'll give you, let's say dy by dx equals to x into y. A dy by dx equation will be given to you. And you'll have two variables, like you have x and y. Okay? And they'll ask you to solve this differential equation. So what you need to know is, first, you need to get this into the variable, okay, the variable separable, okay, the variable separable form. Okay, you need to get this into the variable separable form where you need to keep your x's together and the y together. So I can write this as 1 over y dy, which is equal to x into dx, correct? Here, as you can see, the y's are together and the x are together, correct? Basic rearrangement, correct? This is the variable separable form. Now, what you do is, in the next step, okay, you integrate both sides. Okay, you simply just integrate both sides. So you can write this simply as the integration of 1 over y dy, which is equal to the integration of x, okay, integration of x dx. Now the integration of 1 over y is simply ln y, agreed, which is now equal to the integration of x, which is x square by 2, correct? And as there are no limits here, you add a plus c, correct? So this is basically writing in the form of the or solving the differential equation. Here you get the y's and the x, and then you solve it, you get the value of c, and then finally write your differential equations, which we'll do in the examples which you have below. Okay, but this is the general concept. First, they'll give you a differential equation, you need to write in the variable separable form. Okay, and then you need to integrate both sides and get the answer, correct, with the plus c. Okay, but sometimes they ask you to form an equation, sometimes they give you the values of y and x. Okay, so I've two examples from the past paper, okay, which now we'll be solving. So this is the basic concept which you need to know. Okay, and this chapter is totally based on integration and further integration. Okay, so you need to have those concepts really strong. So now let's go to the past paper examples. This is from 9/7/09/2021, Feb March paper 32. Okay, so the variables x and y satisfy the differential equation 1 minus cos x dy by dx, which is equal to y sin x. Okay, and it is given that the value of y is equal to 4 and the value of x is equal to pi. We need to solve the differential equation, obtaining an expression for y in terms of x. Don't freak out, it's a really simple process which you need to follow. Okay, you might get stuck right now, but just, listen to me carefully. You'll understand this full concept. So the first thing which you need to do is get it in the variable separable form. Keep the y together, keep the x together. So I can write this as 1 over y dy, which is equal to sin x, okay, over 1 minus cos x dx. Correct? This is the variable separable form. Agreed? Now what I simply do is I integrate both sides. Okay, so I'll make a line, okay, in the middle. Okay, so now the integration of 1 over y is simply ln y. Correct? Got it? Simple. Now I have the integration of sin x over 1 minus cos x. Now for this you need to recall your further integration. As you can see, this can be only solved using the substitution, integration by substitution. I take my u as the denominator, which is 1 minus cos x. I calculate the du by dx. The differentiation of 1 is simply 0, and the differentiation of cos x is minus sin x. I get minus into minus sin x. Correct? So I get my du by dx basically as sin x. Correct? Now I basically write this as du by sin x equals to dx. Correct? Now I can simply write this as the integration of sin x over, I have 1 minus cos x, which is basically u, multiplied by, instead of dx, I can simply write du by sin x. Correct? Now I can simply calculate sin x and sin x. So I basically get the integration of 1 over u du. Now what is the integration of 1 over u? Simply ln u. Correct? Now in the place of u, I simply just substitute 1 minus cos x, and yeah, there's obviously a plus c here. So I write this as ln, okay, 1 minus cos x plus c. Correct? This is what I basically get. So now what I can do is I can write this simply as, I have ln y here. So I write ln y, which is equal to, and I have ln 1 minus cos x plus c. Correct? ln 1 minus cos x plus c. Correct? This is what I get. So now what I know is I have y equals to 4 and x equals to pi, and I need y in terms of x. So before I obtain this, I need a value of c. So I know that my y is equal to 4 and x equals to pi. Correct? So now I substitute this. So I write this as ln 4, which is equal to ln 1 minus cos pi. Correct? Plus c. Correct? Now I can write this as ln 4, which is equal to ln 1 minus cos pi is simply minus 1. Correct? Plus c. Now this can be written as ln 4 equals to ln 1 minus minus 1 is basically ln 2 plus c. Correct? Now I can write this as c equals to ln 4 minus ln 2. And I can use the log property, okay, which states that log a minus log b is equal to log a over b. Correct? So now I can simply write this as c equals to ln, okay, 4 over 2, where I can write my c simply as ln 2. Correct? Now I can simply write this as ln y, which is equal to ln 1 minus cos x. Correct? As we had here, correct? But instead of c here, I can write plus ln 2. Correct? Now I need my y in terms of x. So what I basically need to do here is I can use the log property, which states that log of a plus log of b equals to log a into b. Correct? So now I can simply write this as ln y equals to ln, okay, 2 into 1 minus cos x. Correct? Now I can obviously cancel ln on both sides and write this as y equals to 2 into 1 minus cos x, which can be written as y equals to 2 minus 2 cos x. So this is basically y in terms of x, which is basically my final answer. Okay, so this was a very good past paper example. You need to write this in the variable separable form first, then integrate both sides. Okay, then you need to find c with the values of y and x. Once you find c, you simply just need to write y in terms of x, and you simply get 6 marks in your pocket. Correct? Simple, easy. Okay, now let's do another example. Here we'll learn another concept, so please pay attention. So here I have this is from 9709 2018 October November paper 32. Here, okay, in this question, I have a certain curve is such that the gradient at a general point with coordinates x comma y is proportional to y square over x. The curve passes through the points 1 comma 1 and e comma 2. By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. So here, like in the previous question, we were given, okay, a direct equation and then we had to solve. But here we need to form. Okay, we need to form the equation. Okay, mostly in all the questions they give you an equation and you just need to solve. Only in very few questions they ask you to form. Okay, in very few questions. But obviously you need to know it. So we'll do that example. So here, okay, first we need to form. Okay, we need to set up the equation. We know, okay, the gradient. What is the gradient? The gradient basically means dy by dx. So I can simply write dy by dx here. Okay, and now I know that this is proportional, okay, to y square over x. So the sign of proportionality is this, okay, with y square over x. Correct? Now, how do I set up an equation via this? I can write this as dy by dx. You remember direct proportionality. I can write this as equal to k into y square over x. I can simply write it like this. Whenever it's directly proportional, I just multiply a k. Correct? Remember the concept of proportionality which we had even done in IGCSE, correct? Now what I can simply do is, I write this. Now basically I need to start solving because this is my differential equation. Okay, I can write this in the variable separable form. Correct? So I can simply write this as 1 over y square dy, which is equal to k over x dx. Now I can simply write this as y raised to minus 2 dy, which is equal to k over x dx. Now I can simply integrate both sides. Correct? So I can simply make a line here. Now the integration of y raised to minus 2 is basically y raised to minus 2 plus 1, which is minus 1, divided by minus 2 plus 1, which is minus 1. So I can write this as minus 1 over y. Correct? Now I have the integration of k over x dx, which I can write as k into the integration of 1 over x dx. Now I can write this as k. Okay, the integration of 1 over x is ln x, so I multiply k only to ln x. Correct? And after this you just write a plus c. You did not multiply the k to c because c is a constant. Correct? You can just write it like this. Just add c later. You don't need to multiply k. Correct? So I have k ln x plus c. So now I can write this simply as minus 1 over y, which is equal to k ln x plus c. Correct? Now I have this set of coordinates 1 comma 1 and e comma 2. Correct? Which will be needed to express y in terms of x, because first we need to obtain the value of k here and c. So the coordinates I have is simply 1 comma 1. Correct? And I have e comma 2. So obviously this is my x, this is my y, this is also my x, and this is my y. correct? So first I'll take the first set of coordinates, which is 1 comma 1, and put it in this equation here. So I can write this as minus 1 over 1, which is equal to k into ln1 plus c. So I can write this as minus 1 equals to, I know ln1 is 0, so k into 0 is 0. So I get 0 plus c. So I get my c basically as minus 1. Now I need to calculate my k. So for that I can simply substitute e comma 2 in the equation. So I basically get minus 1 over 2, correct? Minus 1 over 2, which is equal to k into ln, and in the place of x I put e, correct? Correct? And in the place of c I put minus 1. So the only variable now I have is k. So I can write this as minus 1 over 2 equals to k minus 1, because I know ln e is 1. So I can simply write my k equals to 1 minus half. Okay, which gives me my k basically as half. Okay, so this is what I get my k as simply. So now I can substitute and write this as minus 1 over y equals to, I can substitute k and c into basically this equation which we had formed here. So I can write this as half, okay, ln x, correct, minus 1. Now I have the final step, which is writing basically y in terms of x. So now basically I need to make y the subject of the formula. So I can simply write this first as, I can take the LCM and write this as minus 1 over y, which is equal to ln x minus 2 over 2, correct? I basically took the LCM here, cross multiplication, agreed. Now I can again do cross and write this as minus 2, correct, which is equal to y into ln x minus 2. Now this can basically be written as y equals to minus 2 over ln x minus 2, correct? And obviously I can write this as my final answer of a better presentation. This can also be written as y equals to 2 over, okay, 2 minus ln x. Okay, both of them are acceptable. Okay, both of them are basically equivalent to each other. This is just, I'll just write equivalent. Okay, even if you just leave it in this form, it's okay. There's no tension. Okay, you'll get all your marks, 8 on 8 you'll get. Okay, I just wrote this for better presentation. Okay, so basically the point is that this is the concept of differential equations. Here we also learned how to form a differential equations, but obviously in the past paper there are hundreds and thousands of types of questions which they ask. Okay, you need a lot of practice for this, because you really need to, because it's a very scoring topic but requires a lot of practice. In some questions they have even asked forming the equation, which can get tough sometimes. So if you get stuck, you can just view our video solutions and get a mastery of this chapter. Okay, so don't skip this chapter. It's a very simple chapter and comes from many marks. Okay, so just practice it. Okay, keep on practicing, and if you obviously get stuck, you can view our video solutions and get a mastery. Correct? So yeah, thank you very much for watching.